Welcome to today's class where you actually code. But before then, have you stopped to maybe even think, imagine what exactly these programming languages are? Like what exactly is happening when you type and run your first code? What is going to happen? Well, that's what we'll be explaining in the next few minutes, along with some of the core concepts you need to understand. So, programming, talking with machines. How we actually communicate with computers is kind of similar to how we chat with our friends. We use something called a programming language though, rather than the normal human language. And you may think of a programming language as a special language that the computer sort of understands. And if you learn the language, then you can tell the computer exactly what to do. Next, let's look at how programming language are used or how they work, how they are written, the syntax, what we mean by syntax, because just like human languages, programming languages also have strict rules called syntax rules. In human language, we call it grammar rules. So syntax dictates how you structure your code, the code grammar, the punctuation, word order, etc. If you break the syntax rules, you have a big problem because the computer won't understand your instructions. For example, a gave book Gary Fred. Did you get that? Yeah, it doesn't make sense. And it's English because the syntax is, the grammar rules were broken, the word order is off. So each programming language has its own syntax rules. Next up, some of the concepts you need to know about programming. Number one, variables. And you should know that variables are very important to know because they make our code more organized, efficient, and very easy to maintain. And we'll be using them extensively throughout this course. So, a little explanation on variables because variables is something that a lot of beginners really struggle to understand. But I'll break it down for you. So, work with me. In English, for example, you can denote an object with it and you can refer to people as she, he, him, or her. So now, for example, you can say something like, give it to him. The thing you refer to as it can change, right? Like the thing you are referring to when you say give it to him, that stuff itself can change, but you still say it. Also, the him you refer to can also change, but you still say him. Just like this montage of scary president and I don't know that person's face. But in all, the listener knows who you are talking about exactly when you say him, even though the actual him has changed. And it's just the same with variables. So a variable is just a placeholder for the actual thing. For example, in English, you may say, his name is Tunde, call him for me. Name there is the variable. Tunde is what the variable is referencing. You understand? So in code, that will be something like name equals Tunde, print name. Let me take a sip of water. So you can see there that name is just a container for Tunde. So in the same vein, variables are just containers for data in your programming, and it's good to use them like you need them. So for example, look at the example on the screen. Let's assume you have 200 places where you need to use the username in your code. So if you type the actual username like Juliet in all those places, when you need to change login details, would you go to your client's computer or would you code a new software for each client? No, you won't be able to change it in all those places. But if you actually did it such that you just use a variable and the variable references whatever is stored in that variable in all the other places, then if there is need to change, you only change what is contained in that variable, and your code will still work. So look at the example there. Look at this example now. The username part. All I need to do is this first line of input. What is your name? Once the user changes that part, you'll see that it changes in every other aspect of the code. So now we've seen variables, and what they contain actually has a name. It's called data. And if you remember data from maybe primary school or secondary school, they say data is raw, unprocessed information. And it's the same thing. You can see in the previous example, when the user types in their username, they are giving information to the computer, but the computer has not processed it yet. So it's data. We call it data. So data is what is in a variable. Now, for your computer to be able to make sense of the data you are sending it, we need to separate all data, classify them into types. Just like we have numbers, we have words, we have digits, we have numbers, words, we have stories, etc. In programming also we have data types. So you can think of data types as different kinds of boxes designed for different things. Just like in real life, you would not really put your pounded yam in the water bottle, right? Yeah. Similarly, in programming, we use different data types for different kinds of data. Just like the boxes you see, you can see integer, float, string, bool, or boolean. So integers, they are used for whole numbers, floats for decimal numbers, string for alphabets, characters, words, boolean for logic, true or false, 1 or 0. So those are some of the common data types we have. Now, if you store data in a variable, then what do you use it for? Like, how do you process it? In the course of processing it, you perform operations on data, and that's where operators come in. So operators are symbols that we use to perform operations on our data. For example, adding, subtracting, multiplying, dividing. Simple maths, right? Yes. Now, take a look at the example on the screen. Addition, subtraction, multiplication, division, they are all the same thing. But look at the assignment and equality symbols. Yes, a lot of beginners get this wrong also. When you want to assign, like the example I gave earlier, you want to assign a value to a variable, you use the single equal to sign, because what you are simply saying is that this variable called age or called name is the same thing as Bob. But when you want to check for equality, like is 2 plus 2 equal 4, you use equal to, like you use that equality symbol. Now, the next one, this one, exclamation mark with an equal to. That anywhere you see exclamation mark, generally in programming, it means not, a negation. So this simply means not equal to or inequality. Here, name is not Alice. Then you have the rest, greater than, on and on. And you have these logical ones, and or not. Now, when performing operations on your programming, your entire program cannot just run, because it performs a task. That means it will need to make decisions, etc. Now, the structures that are in place for it to make that decision, for your program to make sense, they are called control structures. And let's look at the first one, conditional statements. Mind you, a statement in programming is probably the same thing as a sentence in normal human language. Okay, control structures. These are the tools that allow our programs to make decisions or repeat actions. So, starting with conditional statements as a control structure. Conditional statements allow us to execute different blocks of code depending on whether a certain condition is true or false. You get that? Just like you see on the screen here. This particular block that says if this is greater than 50. So the most common type of conditional statement is the if statement. Yeah, you are going to encounter some more, but the most common is the if. Now let's go to the next control structure, loops. Loops allow us to repeat a block of code multiple times, as I said earlier. So for loops, we have two main types. We have the for loop and the while loop. So you use the for loop when you know how many times you want to repeat the code. For example, you want to fetch maybe 8 cups of beans. So you say for number of cup of beans less than 8, fetch one more. That is until when um the number of cup of beans is equal to 8, that's when you should stop. But a while loop is used when you want to repeat the code until a condition becomes false or true. For example, you are fetching water or you turn on your tap. That's a while loop because you leave the tap on and you keep checking the water level until the bucket is full. Can you see that programming is just like in real life? Anyway, before we wrap all of this together in Scratch with that little program I showed you earlier, let's talk about debugging, because this is what you do when something goes wrong. So that means debugging is the process of finding and fixing errors in your code, because everyone makes mistakes. Everyone makes mistakes when they write code. So being able to debug is a crucial skill. In fact, is a sought after skill. Like if you go for interviews, they ask you, the debugging is part of the interview. Now, when we are talking about errors, we have different types of errors. Let's look at 3. Syntax. This is the one you will encounter the most as a beginner. So that's the error in your code grammar. Usually your IDE will tell you where it is. Then you have runtime error. This one has to do with operations, performing operations in your code. For example, trying to divide by 0. That is a very common runtime error. Then we have logical errors. These ones, you may not catch them because, okay, let's go back to that example of if age is greater than or equal to 18. Let's assume I forgot to put the or equal to symbol and it's just if age greater than 18. You know what is going to happen? If the user's age is equal to 18, then nothing is going to happen. And in the course of testing, I might not actually test for 18, but when I deploy the program, people who are 18 years old are going to have issue. So you can see syntax errors is the easiest to catch. But you see this logical error is very difficult. But if you have a good pseudocode, like you planned your project properly, then the chances of having logical errors is low. Now, for syntax errors, logical errors, one of the best ways to debug, even runtime error, is to use like maybe print statements or outputs to be able to see at various sections of your code. Maybe whenever you perform an operation on a variable, you output what the result is so that you can track and see whether your logic, your syntax, everything is correct. All right, it's time to put all these concepts together and actually code something in Scratch. So let's head over to Scratch. All right, so the program we are making here is when you click on the sprite, if the variable is less than 50, it will move to a random location, but once it is 50, it changes the color and sets the variable back to 0. So it keeps going like that. Let's bring out this one to set variable, and then the other one, which is an event block in Scratch to track when the sprite is clicked. Alright, so after clicking the sprite, you want to set the variable to a particular number, and remember operators, we are performing operation on it. So you want to set it to 5 plus number, the value that was there before. Now with Scratch, the data type in the variable is automatically detected, so there's no need to declare that this is a number except you want to convert or something. But next, after doing that, we want to wait for 1 second. Now that one there is also a variable because we can easily change it. Then we are bringing in another control structure, the if then else, if else block. So the condition we are using for this if block is if the variable is greater than 50. It should do what? Change the color. You'll see that under looks, then change color by 25%. Alright, then in the else aspect, we want to move the sprite to a random location if the variable is not less than 50, since the condition has not executed. Then also, if the condition executes, we want to reset the variable back to 0. Alright, so let's test the code. You can see when we click it, the variable increment. Let me show you. Let's make the variable visible. You can see it increments to 10 from 0 to 5, 10. And when we click it, it also goes to a random location. So this is the classwork you are going to do. This is what you are going to do, and you recreate this and submit. And then, since we've not done the pseudocode, I want you to just explore Scratch blocks and add your own thing, like make it unique for yourself in your own way. And this will be submitted by, so the admin that will be accepting it would signify in the group. See you on Wednesday.